Okay, so section 2.2 is about finding the trigonometric ratios of any angle, and we're doing angles between 0 and 360. Okay, so not concerning ourselves with negative angles or anything, although it doesn't make it really any more difficult if you did. That's just how we're starting off. Okay, so to find the trig ratios of any angle, okay, we can say that we have any angle in standard position. Okay, and it really doesn't matter what quadrant they're in. I'll just show you for the first quadrant here, and then we'll kind of look at the other quadrants in a minute. Okay, so let's say we have an angle in standard position. It's going to happen to be a first quadrant angle. And let's say that we have a point P with x and y coordinates that's in the the terminal arm passes through. Okay, and so we would just say that distance between the origin and point P is r. Okay, and if we just drop a line segment down here, straight down, okay, down to the point directly below the P on the x-axis, then you're covering a distance of y, okay? And then this distance is going to be x, okay, because this y, that's this y distance, that's the y coordinate, so obviously between y and 0, that's how much you cover, and then this x distance between the origin, that's the distance between the origin and the x value that we have, okay? So here's what we do, and we've always done, we have a triangle here, right? Because this is a vertical line, and the x-axis, you're going to have a right triangle. So we can use sine equals opposite over hypotenuse, right? We're going to use SOHCAHTOA. And so sine equals opposite over hypotenuse. And we're just going to switch this up a little bit because it becomes useful later. You'll see it in a later example when you do, say, a 90 or 180 or 270-degree angle. But the opposite over the hypotenuse here for this is our angle in standard position, is going to be y over r, okay? Cos, okay, so cos is going to be equal to the adjacent over the hypotenuse. Okay, so that's going to be x over r, and tan, we know tan is the opposite over the adjacent, and so tan is going to be y over x. Okay, so instead of having SOHCAHTOA now, we also have this option that says Sir Tix. Okay, and that's how you remember that. Okay, so when we decide to use the y, sine equals y over r, cos equals x over r, or t equals y over x, that's how you remember it. Okay, let's take a look and see what happens when we have different quadrants. I hope that you can see this. It's not really that huge, but okay. In the first quadrant, obviously, we're starting up right here. Okay, between 0 and 90-degree angle. You can just see that y is positive, x is positive, and r is positive. And r is always positive. Okay, it's just going to be the absolute distance between the origin and the point. But we do give directions to x and y depending on whether our x and y coordinates are positive or not. Okay, so because both the x and y coordinates are positive here, we're going to have a positive sine value. Okay, we're going to have a positive cosine value, and we're going to have a positive tan. So sometimes we do this, we draw the quadrants, okay, and so we put an A there to say that all trig ratios are positive in the first quadrant. In the second quadrant, you still have a positive y, but now you have a negative x, okay? So that's going to leave your sine positive, that's going to make your cosine negative, and it's going to make your tan negative. Okay, and so we sometimes put an S in the second quadrant to remember this, that sine is the only primary trig ratio, okay, out of sine, cos, and tan that's positive here. In quadrant 3, we have both a negative y and a negative x. Of course, our r is always positive. Please remember that your r is always positive. That's going to give you a negative sine value and negative cos value, but when you put the y and the x both in tan, they cancel each other out and you get a positive tan. Okay, so tan is the only trig ratio that's positive in the third quadrant. And then in the fourth quadrant, we have a positive x again and a negative y. Okay, so now we have a negative sine, a positive cos, and a negative tan. Okay, so C, to say that cosine is the only one that's positive in the fourth quadrant. And sometimes people remember this. I like this because it starts in the first quadrant and goes 1, 2, 3, 4. We would say all soup turns cold. And I just remember that all soup turns cold. So I remember that it's all trig ratios positive, then quadrant 2 is sine only, quadrant 3 is tan only, and quadrant 4 is cosine only. Okay. Now this is all I'm going to do for this lesson, but there is an important part of, I guess, one other thing that you need to do, and that's included in example 5, I think. Yeah, example 5, it tells you how to solve for the angle given their sine, cosine, or tangent. So I've just put that with example 5. So if you're not watching the examples, but you are watching the lessons, you're going to want to watch example 5 here.